Hello guys, welcome to my channel and let me introduce myself first. My name is Arnav Goyal and I am from third year in Preparatory Sonipat doing BTech in CSE. So without any much further delays, let's start with the question. The question is on the port forces and it's QED's favorite permutation. So QED is given a permutation, it's a P of length n. So what is a permutation first? Let's know that first. Okay. So the permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. So basically, let me explain it. So permutation is what? Of length n is what? That is all the elements from 1 to n should be present in that permutation in that array, and no repeating values that should be present. That is, if the length n equal to 3, then the element should be present. That is 1, 2, 3, not 1, 2, 2, like this. For example, let's suppose it's a permutation, but this is not a permutation since n equal to 3 and 3 is not present at all. And all have to be distinct. All the elements of the array has to be distinct. So here he has also a string s of length n containing only characters L and R. So there is a permutation first of all, and there is a string s, and it's both of them's length is same. That is n, and the string s contains L and R. QD only likes permutation that are sorted in non-decreasing order. So the non-decreasing order means by the elements array has to be in a sorted way, that is in an increasing order, but the elements that is the previous one and the current one can be same also. To sort P, he can select any of the following operation and perform them any number of times. So we need to do is to sort the permutation, and we can use any operation any multiple of times. So he can choose an index size. If that S of I equal to L, then he will do, that is P of I and P of I minus 1, that is the previous one. There he can swap both of them such that S of 1 is not equal to L. Since if S of 1 is equal to L, then it will go out of bound of that array, of that permutation. And if S of I equal to R, then he can swap P of I and P of I plus 1. So S of n equal not equal to us, the both the same reason, that is it will go out of bound. So we have few queries, and in each of the query we have an index I, and we have to change that S of I. That is, if S of I equal to L, then it will be changed to R, and if S of I equal to R, then it will change to L. So note that changes are persistent. So these changes are persistent. So for the query, first query, if you change the S of third equal to R, then for query two, it will be remain same. That is, the new string will be used for all of the queries. After each query, he asks you if it is possible to sort P in non-decreasing order by performing operations any number of times. So we can use any number of times of operation, and if it is possible to sort or not, we have to output that is yes or no. If we can do this, then well and good. Else you can just print out no. So note that before answering each query, the permutation P is at its original form. So if the first query is done, and then you check if we can sort or not. If we have sorted, then we have to use the original one permutation for all of the queries. That will not be a persistent for all of the queries at all. So input, that is test case, and then Q is 3 into 10 to the power 5, 2 into 10 from 2 into 10 to the power 5, same with Q. And we have some permutation elements, and this. And we have to output in no and yes. So I hope we get the question first of all. So what is present, that is given, that is S of I, a string S. So we have given a string S that is contains L or R, and a permutation P that contains of elements 1, 2, 3 up to n. So we have to sort it out. Okay, we have to sort it out the P, and then if we can sort it out, then we will say yes. So what can be the cases at all? First of all, let's think that uh, we can do with the brute force first. Okay, so go to each query and then check that we can sort or not. Like if we can sort or not, if we can check that way. So just then you have to do many calculations so far. But if we go with an easy way, if we go with an easy way, and yeah, the brute force one will also have a time complexity which is more. The reason behind this, it will be, I think, minimum to minimum order of n square. Reason behind this, we are for each query we are uh, moving. At least we have to move for all of the element. That is order of n, and for all of the elements we are moving. That is also post order of n, and that will be all around to be order of n square. So brute force doesn't work at all. Doesn't work at all. So so what can we think? What can we think? So what can we think? So what if what if the permutation is sorted? What if the permutation is sorted? So we will just say our answer is yes. Else we say the answer is no. Wait a second, just I think I have to buy a new mouse because I don't know it's not working properly. So never mind, let's start. So yeah, uh, so what if the permutation is sorted? If it's sorted, then we will just say yes. Yeah, the answer is yes. Whatever the case of the string, it may be L or R, whatever. We don't care. Then we will just say yes. What if it is not sorted? Then things will dependent on the string that can we arrange or not. Okay. So let's move to the string first. So what if it's L, 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 and L like that, or maybe R, R, and R? All of that present in that, all of the string is consisting of only L or R, or maybe both of them. This is the only possible case so far. What if it's consisting of all of L? That means L, 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 and 3, 4, 1, 2 is the sample test case, let's say. Since we know that we cannot do for this, but we can do for this the operation. We can apply the operation. What we want? We want that the one should be go to its actual place. That is the first index. So we know that we can do is like swap this and then swap this. That is, it will become 1, 3, and then 4 and 2. Then we can swap this for same with 2. That is, it will become 1, 2, 3, and then 4. Hence we can sort it up. So we can sort it up actually. So this means like if there is consecutive L, or maybe, or you can say that all of the L is present, then we can, if we can sort the things up, like whatever the order it is, like 1, 3, 4, 2, it is in a non-decreasing way, and permutation becomes a non-decreasing way. Or if only a subarray of L is present, then it means that whatever the order of the L of that subarray, that is 1, 6, 7, and 8, we can make it like 1, 6, 7, 8, like that. Same goes to for the R. If R, R, and R, and same R, 4, 3, 1, 2, we can just see that, okay, so we need to swap 4 and move it to its correct location. That is this location. That is for fourth index. So the swap, and swap. That will 4, 3, and then 1 and 2. 3 also goes like the same way. 3 and then 1 and 2. Same goes with R. So if multiple L are present, or multiple R, or you can say if only R present in the substring or only L present, then we will say yes. But here we can get also like if multiple consecutive are present in a if present. So we can say that we in whatever the order the elements are present, then we can sort it up. Let's say like I have already told you here 8716. It can be just do like 1678. Same with R, we can do it. So what what is the possibilities now? Like R, L, and LR. present in the string. So if R and L are present, let's suppose. So then let's take an input case. Maybe 4, 6, 9, and 2, 7, 3, 1, and 5. Okay. So R, 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 L, 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 L. Okay. So we know that from here we can say that they R can start from its the next one, next index. And we know that this whole can be sorted in a sorted way, can be present into a sorted way. Sorry, wait a second. 2, 4, 6, 9, and 1, 3, 5, and 7. So we know that we can swap both of them since L also do with this prevent previous element and R its current and the next one element. So it will become 2, 4, 6, 1, 9. Here's a gap 3, 5, 7. Then what I will do, we can sort this thing up. That is 1, 2, 4, 6, 9, 3, 5. Wait, sorry, 3, 5, 7, 9. Then we know that 3 has to be presented here. Then we again then do the thing, same thing. It will be 2, 1, 2, 4, 3. It will sort up and same with 5, 6, 7, 9. So from here we can say that if RL is also present, then whole traversal can be done, that whole swapping can be done, and we can make it in a sorted way. But what about L and R? If there's a what about L and R? Let's suppose we take the same input 2, 4, 6, and 9 since and 1, 3, 5, 7. Okay, so since L only can swap its current index and the previous index, so there is a gap so far. So we cannot swap at all. So uh, we can sort it up like we can make it in a sorted way, and the whole things then becomes like 1, 2, 3, 4, 5, 6, 7, 9. Let's suppose 9 rather than 9, it's 8. So you can see like okay, now we can say yes because we have made what the question was saying us to do. But there is no traversal can be done so far. So for this situation, we will say no because we cannot just put one to its correct location. So for L and R, we say it is bad case. It may be said that it can lead us to an answer that is yes, or it cannot lead us to the answer that is no. So from here we can say that L and R is our the main problem. So, okay, now since queries are present and we know that Q queries, it's better to pre-compute the things rather than to calculate it at the current queries time because it will lead us to a time complexity that can go for more than 10 to the power 8 or 1 second or 2 second you can say. If wait a second, so how can we do like because we are then just L and R then check is all sorted or not. Because RR or whatever it is, we say that these things doesn't matter whatever it is, then we can sort. But for L and R, we don't know like is this all sorted or not? Is this all sorted or not? That is it's really a bad element or not. So doing that will cost again us around order of n square. So we cannot do that. So what we can do? We can do is like what if L is present here and R is present here. That is, this is the bad element. I mean that let's suppose there is an array and it's 4, 3, 4, 3, 1, 2. We don't care about the string right now, but we know that what if here is L and his are present. Let us suppose that the bad element is present at here and the rest of things are just okay, R, or whatever it is. But only this is the case where the bad element can be present. Because we don't know like inquiries like it can be because it can change, it can alter. So from us our purpose we can do this like okay, what if we can put L at here and R at here and then check which can be a bad case or a good case, a bad element, sorry. So why are we doing like this? Because the permutation is permanent, that is that cannot be changed at all. So that's why we can do this thing. That is, if L and R is present and we know that this is always the same case, so it doesn't change. And whatever the condition, whatever the queries we do, it will remain gives us the same answer. So what if we do is like 4312 and if here is present L and here is present R. So we do this like, okay, so here for present, because 4 cannot be present at all, we will say it's a bad element so far, that this position gives us a no. So if L and R is present, then we cannot sort it up. Like if L are present, then we cannot do one at its correct location. Then same at here, if L present at here and R present at here, we'll do it different color. If L present at here and R present at here, if uh, L present at here and R present at here, then again can we like do those things like is it a bad element or not? The same thing comes to our mind. Okay, so we cannot do this like 4, 3, and 1 is not its correct location. That is the minimum value is 3 and the maximum value is so far as 4. So we can't do that. Now again, if L presented here and R presented here, so can we swap? Can we do those swapping? Is it a bad element or not? So minimum is 1. So yeah, one can lead us to here. Wait a second. If L present at N and R present at A1. Sorry, we cannot do this because this is also bad element. We cannot swap because one at present and it cannot move to its correct location. Then at here, L present at here and R present at here. Since whole swapping can be done so far, and 1, 2, 3, 4 can be made, then we can say, yeah, we can swap and the answer will be correct for this index. If L and R are present at here, sorry, if L present, wait a second, if L present at here and R present at here. But for all of the indexes, then we says no and no. So this way we can find out for all index bad elements so far. What will be the bad elements if L and R will be present. After doing that, I will definitely sure I will also explain with the input case that is present in the question, but I will explain like what is we will doing. So after that, we will move to each and every query and take a set also that and take a set also. And after that, we will move to each and every query. Sorry. So we know that we first of all we will store that this index is a bad case. This index is a bad case. This index is a bad case, and we will store it in our set. And then we will move to each and every query and then check if we change. Like first of all, we will check is this index present or not. If this index is present, so first of all we will remove, because if we will remove that from the set, because this L will be changed into R. So this will be a good thing at all from our the way that we have stored in the set. So we will remove that into from our set and then check if the condition same L and R present, and is that in a is it a bad element or not. So if set size is present, then we will do. Like I will explain it with the question, what I have done in the code. So first of all, I will go, yes, I will go with the input test cases. Okay, first of all, I will go with the input test cases. So again, what we will do? It's 1, it's 4, it's 2, it's 5, and 3. First of all, what we were doing? We were doing is to check out which one is the bad elements or not. That is L and R. Since 1 and 4, we cannot sort the things. But yeah, wait. First of all, we will check is L can be present or not. That yes. So this part and this part can be as a good element so far, because wait a second. Yeah, it's because 1 is presented here and R is presented here, that because and we can sort this up, and if we sort this up, if there is no traversal in between, then it will be 1, 2, 3, 4, 5. So it's a good case at all because like one is present at it's the location that is it has to be. That is the first index. And if there's no swapping at all, if there's no traversal in between them, that is there's a block wall, if we say. If there's a wall in between them that we cannot swap between them. There's no traversal at all. So one is present at here, and if all are R, then one, two, three, four, five. Yeah, that's the what we wanted to do. It's the question that asks us to do. Have we have done? And we will say yes. And after that, wait. After that, what if there's L and R at here? If there's a block at here, wall at here. So one and four. Okay, you can do that, and then you can do this. Sort it up. Then we know that there's a block and there's no traversal at all. The required that we have to do is not being fulfilled. So we will say no. This is a bad element. If L and R is at here. Same, we will check for all of them. That is uh, L at here, R at here, and since we block both of them, the same situation will happen. And if L at here, R at here is blocked, the same situation will happen. Like 5 cannot go to its own the location that it wants to be. And at last, if L at here, then all things can be sorted up. That is all L if we say. So we have make a set, and if we say that at 2, that is R, L, R, L, L, and 1, 4, 2, 5, 3, and yeah, no, 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 okay. And if second part is changed, that is becomes to R. Since R, 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 L, L, that we says yes, we can make things okay. Like yeah, the way that we want it has been fulfilled. Wait. So it has been fulfilled and that this is a correct case. Now if we change for at fourth index, one, two, three, four, that is we change it to R. It also like R and L, there is no LR present at all. So we will say yes, bad elements are present at all. If at third, if we change this to L, since we know that L and R are the bad case, but we will check this thing. Since it's a cross sign, that means we are cannot do this way. Like we cannot sort it up in a non-decreasing way that we want. So we will say no. I hope you get it. So let's go to the fourth part then. So wait a second. So here we are. So first of all, we will take int n and then int q. Then we will just input it up. Then v of I. Let me tell you, v of I is vector of int. So vector of int is v of n. And then take we will take all the elements. We will take all the elements in the vector. That is, you can see it here. Then we will just introduce in temp equal to v of 0. And then the set that I have already told you, that is all the bad elements all the bad elements index we will put at here. Then vector of bool is sort on. I will tell you why we are doing. So first of all, we were doing like for each element that is minimum is this and maximum is this. That is to find out that that is one, two, three up to I. Can they be uh, can they be just put at the correct location or not? So we will just take out the minimum and the maximum so far, and then we will take a val temp that will store the values of that permutation, and then we will push back. If maximum minus minimum plus one is equal to temp outside. So why we are doing this? Wait, I will just take this and explain it here. Wait. So this is a good thing to note that if we have to find out like 4, 3, 1, 2. So we have to find out like is 1, 2, 3 up to I are whatever their order is, order is that we can sort it up or not, like from one to the ith value. That is the consecutive way, you can say. Like the consecutive way, can we do that or not? It's just the whole algorithm do so. That is at here. 4. We just push 4. And the maximum and minimum plus 1. That is 1. That is the size. Actually, this is what is doing is size. So 1 is equal to 1. That's good. But minimum is equal to 1. Not at all. That is 4. And maximum equal to I plus 1. That is not at all. That is it's not 1. Then we move to 3. Then we will check again. Minimum is this, maximum is this, but both of the sides is 2. Uh, Sorry, minimum that is 2, yep. But say minimum is not equal to 1. Then here we will do go. Can we do like minimum equal to 1? Yes, it's good. And maximum minus 1, that is 3. 1 minus 4, that is 4. 3 plus 1, that is 4. That is 4 is not equal to well temp dot size. That is, it's not equal at all because 2 is not present. That's why. And maximum equal to I plus 1, that then we can just move to this and the same thing we will do. And if we can do this, like that is 1, 2, 3, we can do this since we have sorted up. Since we don't, that this is not a bad element so far if L and R are present. So we say that is sort, like you can name it any variable, but I go with is sort. So is sort I equal to true, that we can sort it up without any swapping at all. Else is sort equal to false. We will just say false at all. I think you get it. Now we will just move and for int I equal to 0, I less than n minus 1, that is iterate. If s of I equal to L and s of I equal to R, first of all, for every the string that is present, then and s of I equal to 4, that we cannot serve. So that means it's a bad element, then we will put that in that index. So we will say first of then iterate to all the set to the string that if there is L and R present, and s of I equal to false, then we can say that we can just put those index, that is the bad element index in the set, and then we will iterate to all the queries, that is index c and x minus minus, because it's a zero based indexing. And then see this part, this is an important part, like you can do it in the both way, it's upon you. I go with this. So if like first of all we will check if that set, if that element that x is present or not in the our set. If it is present, so we first of all we will try to remove, because L and R is there and we know that it's a bad element, but we are just changing it to R. That means it becomes a good element at all. So first of all remove this. So we have removed this thing in the set. Else if this part, yeah. So what I was doing, like 4, 3, 1, 2. I'm just storing this part. That is, suppose L and R present, then I am storing only Lth index, not the Rth index. Because this is like you can do it in your way, like I think so. I go with like storing the Lth index rather than Rth index, because like it will create an issue maybe. So that why I just go with to store the Lth index rather than go with the Rth index, because they both are like bad elements. So we store only one index, that is I store with go with Lth index. So that's why I go with that. And if x is not equal to 0 and x minus 1, that is if the current one is R and the previous one is L. If the previous one is L, so remove that, okay, because it's a bad element at all. So we will remove x minus 1, that is that index from the set. Then we will change that if at that at x index s of x equal to L, then make it R, else go with L. After all, what we have done, if x equal to n minus 1, this part. So first of all, we will check if x equal to is not equal to n minus 1, that if s of x equal to L and x of x plus 1 equal to R. For the, like doesn't go out overflow, out of bound, sorry, and for s of x equal to L and s of x plus 1 equal to R. If that's do so, Then we will check is sort of x equal to false. Like, is they are really bad elements? So if they are really bad elements, then we can store in our set. Else, and again, if s of x equal to r, then the same way. If the current one is r and the previous one is l, so and the both are also a bad element, so we'll store that also in the set. So if the set size if set is empty, that there is no bad element, so we will go with yes. Else we will go with no. I think I have explained it a better way, and I have done like I think you get it. There's also a way, like how can we approach this problem too. There's another way. This way I've done by my own, and I also see the editorial. Wait a second. I will explain it too. That part too. Wait. You can code it by own. I will just try to explain this. So first of all, through a series of swap, we can swap elements and let me explain that maybe you cannot get it from there. So first of all, we know that L and R are bad elements and all are not at all. So we what we will do? What we will do for that? Since wait a second, we know that uh, L L are good and L R are not good. So let's suppose there is an array and here 4 is present and here 3 is present. So we know that there must be a traversal such that wait, there must be a traversal such that 3 should be present at here. So like whatever the case, I don't know about L and R, I don't know about anything. I just want that 3 must be present at the third index. I want that one part. So what I will do that is there should be a traversal, there should be a swapping between only these, but whatever the else part I didn't care. I only care about this index. That about this three. So I wanted it must be present at its correct location. So what I will do is to do like minimum of this and maximum of this. There will be a swapping. There is a traversal overall. Like minimum of 1 and 3 and maximum of 3 and let's suppose whatever the value is there. So there will be a traversal at all. Like I will explain it here. Like the minimum of this and maximum of this. That I and the position of I of that value. So first of all, we will do that is to check like what is the where we wanted to put that value and the traversal overall. That this is the traversal. First of all, we will find out that is to iterate all over the index. Sorry, all over the array. That is for 3. We know that it has to move to this to here. That is minimum of that algorithm that you can like if position like you can see it here. Minimum of this and maximum of this one. So like minimum of I, that is the ith index, that is first. It's present at the first index. And where it wanted to go, it wanted to go at 3. So it wanted to go at 3. So there will be a traversal between 1 and 3 at anyhow. Or maybe it's present 4. So 1 and 4. So there will be a traversal between this. So here comes uh, I also see the editorial. Like I also had to know what a great thing I get shocked to. Because we know that about difference array. Here difference array is used up. We know about difference array. So we what if we do that plus one at here and minus one at here? Because what is difference array so far? That we don't care about this and we don't care about this. All things should be presented here and there will be a traversal. Actually a traversal. That is all things should be presented here. And there's a like a communication you can say or in between all of that subarray. So that condition is fulfilling at all overall. That is difference array. We don't care about this part. We don't care about this part. We only care about this part. We only care about this part only. And there must be a traversal at all. So here comes difference array. I will explain also this part also to you. So let's suppose we come to this thing. Okay. So what we will do? We will just put plus one, and at here minus one, because we can traverse, because this is a good thing. We can just move it here and then move it here, and then we will just stop. We will not do like in difference area. What we will do at r plus one, we will do minus one. But to know that we have to stop, like we have to put minus one at here, because this is the exact location that we have to go. We cannot go at much further distance at all. So we have to pause it here. So we will put minus one. So we will do for all the elements in that array and iterator, and then just do this part. Do this thing. Let's suppose four, three, one, and two. Okay, so we put plus one, then we plus one for this phone. We put plus one and then minus one. We put plus one and then we put minus one. Uh, we put plus one, like that way you can understand for all of the element. We will do that thing. No, not sorry. Just wait a second, because this is actually what time. Wait a second. Only this part, okay. At here minus one and at here plus one and at here minus one. That the difference is everything. Then we will do prefix sum, and then that wherever is zero present, like suppose after all that we have done, there is three present at here, and let's suppose there is two, and here one zero, and at here one. So this what this mean by? This means that there there is element that is present and traversal that is present that has to be done. Like here the element is present and it needs to move to this, move to this. Same way if there is greater than zero actually. So there must be traversal, that there must be travel. There is swapping has to be done at all to make things sorted. But if zero is present, if the zero is present, then it doesn't matter. It's doesn't matter because the overall thing, like this overall thing is correct. Is also is all about sorted. If one present, then the same like greater than zero, then we can say that here things must has to be traveled. That here things has to be sorted out, made to be done. So let us suppose here L and R present. Since L and R present, and we know that this is like if we put a block at here, and we know that this whole thing's sorted. Since zero is present, that this gap is not used. So this gap is not used. So whatever you do, there is no traversal at all important so far. So we can just sort it out and sort it up, and just thus after all, like what I have done for each and every query, we will do that part the same that I have done. So I have explained both of the methods, the editorial method and and what the method that I have used for this question. I hope you get it. So that's on my side. Bye. Uh,